electric circuits. Before I start with the electric circuit and how the electric circuits are formed and what it consists of, we have to talk some times only something about Ohm's law and his. He is a scientist. He is he discovered an equation to find special things in electricity, and his discovery was very important. Let's see this video first to enhance our understanding about Ohm's law. First, Ohm, he tried to watch about an electric circuit. Look what is Ohm's law. He said the current passing through a conductor, and there's two things we need: the resistance and voltage. Okay? Now, as a circuit, he adds a battery. The battery has two parts. It's connected to a switch. Now, this battery has a voltage. What does voltage mean? Voltage means it's like I want to know the potential energy inside the battery. It's the potential energy, or we call this is the differences in electric potential energy between two parts of the circuit. Just a minute. Yes, Jude. So again, what is Ohm? He first talk about the voltage. He just used the battery with the circuit, and he let the electric charge to move through the wires. Now, why the electric charge? Please, darling, mute your mic. He used the voltage. Voltage means the potential energy inside the battery. Voltage is related to the potential energy by charge. The potential energy by charge. So what the meaning of voltage is the potential energy between 2 points. The difference in the potential energy between 2 points. Now, let's see how the electric charge are moving, and we measure the voltage by the word V. We say that by it's V 0.3, the voltage of this one, and ampere, it's the current. Yesterday we said the ampere with letter A is the current of the electricity. It's the unit of the rate of the current in a given time. So I have A, ampere is the current. V is the voltage by V. We use it to know the difference in the electric charge potential energy. Now, on continue, he talk about, now let's he connected the voltage, and he put two batteries. Now the current, look what he did. Sorry, he add one battery and he let the current be connected. He closed the switch. He used to see the voltage, and he saw also the ampere, the current. We said that he add one battery and he measured the voltage, and the ampere. The ampere here was 120, the current, while the voltage was 1.3 voltage. Then when he add two battery, what happened? He add two batteries here. The voltage become 200 ampere, while the voltage only 0.5. So nothing's double. If he add three batteries, what will happen? Three batteries. The ampere becomes 300. The voltage only 0.75. So there is relation between them, between the number of the batteries and the voltage of the cell. So what he do? He find an equations. He said that some of the batteries conductors, when the current passes through, they make a resistance stop. He stopped that. So Ohm's observations, Ohm found that the current and the voltage and the resistance in a circuit are always related in the same way. So Ohm, he brought a circuit and he changed the voltage and he see the current by ampere and the voltage by V and the resistance when the conductor said no or stop, resistance in a circuits are always related. How they are related again. So what do Ohm do? He discovered the differences between the current and voltage and the resistance. The resistance of most conductors does not depend on the voltage. The resistance of the conductors. Some of the conductors let the current to move easily. Other conductors doesn't let it to move easily. So what is the law of Ohm? What is the law of, we call that Ohm's law. Ohm's law is represented as a triangle. Resistance, voltage over the current. Will come down. So resistance is voltage divided by current. So to make it easy for you, in this part, I have the opposite shape. At the top of the triangle, I have V. So the resistance of the resistance of conductors are represented by voltage divided by current. Voltage divided by current. Again, the resistance is voltage divided by current. And also we can say the current is voltage divided by the resistance. So the voltage is the difference of the charge in 2 points, the voltage, and we the unit of the ohm, we call it like this. It's equal the volts with V divided by ampere. So this is what we call it the ohm. So this one is represented in ohm. This is with V volt and this is with A ampere. So Ohm, what he discovered? If I change the volt, the ampere will change at the same rate. Again, ohm is the voltage divided by ampere. Volt divided by ampere. So we can change it in any way. So we have to keep this in mind. V is an opposite of the top of the triangle. I have R, the resistance by ohm, and I have the current by ampere. Here, of course, it's multiplication between them. If I want to know the voltage, I have to multiply the ampere with ohm. Let's apply math, and it will help us. Now, a multimeter is a device that can measure the current in the circuit. So, it measures the current, and the current R by ampere. Use the reading on the multimeter and the battery to find the voltage and the current. So they need the voltage and they want the current in this circuit. Calculate the resistance of the bulb. Now I have this is the multimeter. I measured here. The multimeter is used to reading. Wait just a minute. So I am in page 176 that measure the current by ampere. So I have ampere. So again, I will draw my triangle. I have here V, I have here R, and I have here C. I know C. I know ampere, it's 6.54 ampere. And look for this battery. They show us how many volt is it. Dana, can you help me? How many volt is it? Asia, can you help me? Jude?
Yes.
How many volts? It's written on the battery. You can find it. You just read it. 6 volts.
volts.
So what is the equation I have now? Division or multiplication? If I have 6 at the top and 6.54. What?
Division. Division.
Division. Amazing. So it will be 6 over 6.54. It's almost less than 1. Okay? So it is about, I will calculate it to be specific. So it's 6 divided by 6.54. It's about 0.9. What is this? This is the resistance. It's ohm. Okay, by ohm. Now, thank you, Jude. Please mute your mic. Now, batteries gradually lose voltage because we use it. It loses voltage. A circuit contains 2 ohm. So I will clear now this and this and this. Now I have another. It's 2 ohm. Here I will write 2 ohm of resistance and an old 9 voltage battery. 9 voltage battery. 4 amps of current run through the circuits. What is the actual voltage? It was 9 and I have now 4 ampere. Okay, they said it's an old 9 voltage, so Let's see. How can I find the actual voltage? The voltage is missing. So how can I find? Zaina, can you help me? Zaina, the 9 is old. Now I want to calculate to find the voltage. What I have to do? Zaina, Asya, Dana, Al-Ghala. The missing is voltage. Jude, do you know what I have to do here?
Yes.
Yes, please.
Multiply 4 by 2.
So I will multiply 4 by 2. It will be 8 voltage. So it's 8 voltage. So it was 9.
Asya is not
And,
here. Al-Ghalas here.
okay. So it was 9 volt and now become 8 volt because I use it because the energy inside it, the volt, as we say, it's the potential energy in the battery are used to make this light on. Now, suppose you tripled the voltage in a circuit. You treble. That means 3 times the voltage in a circuit, but kept the resistance constant. It's the same resistance. So, again, I have volt and I have ohm. I want to talk about what happened to the current. So now, the missing things is C. The missing is the current. I'm talking about volt and the resistance. So it is division. So what happened to the current? It will treble, will be the same or thirds of the original current. Again, let's see the current is here. Okay? And the equation now, division. The voltage are 3 times the old one. The times V. I don't know what is V, but it's triple times. And the resistance are the same. So here is the ohm or resistance. So this is the old one. And this is the new one. So they asked, what happened? Does it stay the same? No, there is a 3. So it not the same. But what happened? It become treble or third. Treble mean multiply 3. Third mean 1 over 3. So treble mean multiply 3 and third mean 1 over 3. So what did you think happened to the new one? This is the new. Is it multiply with the old one? Did I make it treble or third? Zena? Dana? Jude?
Yes.
Yes, darling. So what do you think? What happened to the current? It's multiplied. It's triple time. 3 times it's triple or third of the original current. What did I do to the new one? I multiply it with 3 times the old one, or I make it a third. I have to divide it by 3.
I will multiply it.
Yes, so it's a triple. It's a triple. Because I wrote here 3 times the old one. So it's a triple the origin current. Now we keep talking also, and I will upload for you today revision on Ohm law on Classera. Please try to do it. Now we keep talking on the electric current, but we didn't mention what is the circuit made of. The circuit is made of important things. This is the circuit. We draw it as line. This line are the wires, are conductors. We draw an energy source as a battery. The long one is positive and the short one is negative. This is negative and this is positive, the source of energy. And we have switch that let the electric charge to flow or to stop. Switch. So, four ingredients for the circuits: wires, conductor, energy source, and switch. We have here, we call that loader or light or fan or machine that use the energy from the battery. Because if you remember that the electric charge are conserved, the energy are conserved. Here I have potential energy. It turn into electric charge, make move. But where this energy move? Change to what? Maybe turn into light in the light bulb. Maybe it turned into heat in the heater. Maybe it turned to kinetic motion as the fan is just moving. So, what are the important things in the circuit? What is the circuit made of? Number one, the battery. Here, the example of the energy sources. I need the energy sources that apply the voltage that causes current to flow. Without battery, the current will not flow. From where I will get the electric charge? When the energy source is a battery, current flow from the positive to the negative end. From the positive, this is the current. We will learn that later, inshallah. So this is the first one. So number one is the energy source. Number two, energy always conserved in the circuit. Electric energy does not get used up. It gets transferred into another form of energy, like heat, light, mechanical, or sound, like the doorbell. Now, all the appliances that we use it, such as the toaster, transfer electric energy. These devices resist the current. So they are represented in a circuit as we call them resistor. Resistor, because they use the electric current. They use it. We call this resistor. Resistor. Electric current are connected. Where is the path is? Where is the road for the electric charge? What we call them? By conducting wires. The conducting wires complete the path. So it's the path, it's the road. We call them conductors, wires. They allow the charge to flow from the energy source to the device that runs on electric current and back. So it's the way, it's the path. So number three, it's the wires. So number one, I need source of the energy. Number two, the resistor or appliances or anything that use the electric charge. Number three, the conductors or the wires. Number four, not all of them, some of the electric switch, often included to control the current, but it's not obligatory. But it's better to use the switch to control the current. When it's open, it breaks the circuit and the device will not work. The current will not flow. All the parts of the circuits are shown here, are the and here as a symbol. So to make An electric circuit, we need four important things: the energy source, the resistor or the device, the appliances, and number three is the conductor, the road where the electric will flow, and optional to use the switch that make the current flow or stop flowing.